So next speaker is from Spain. I would like to introduce Professor Carme Torras. Is research professor at the Instituto de Robótica Informática Industrial in Barcelona, where she leads the large group on assistive robotics. So please welcome.
Thanks, Kenji, for the introduction, and good morning, everyone. Today, I'd like to convey a couple of lessons we have learned in trying to deploy robots into healthcare real environments. We faced, our group, a huge reality gap. And the usual procedure of developing prototypes like those shown here at the lab and then doing the technology transfer does not work. So for instance, this could work for sim to real, closing the reality gap in sim to real, but not in this type of environments. So we developed like two strategies, which are the two lessons I like to show. One is co-creation with all the involved parties in an application, and the other is sharing the same ethical stance among all these parties. So the thing we did 2 years ago was to involve the administration and several research institutions in order to build an open lab for assistive robotics so that everyone could get together and share technology and share experiences, share knowledge in short. It is led by the government of Catalonia, and the office is in our lab. And not only administrations and research institutions are involved, but also technological centers, companies that provide assistance at home, and large hospitals, and also robotics companies, like, for instance, PAL Robotics and Salto. So I like to share two experiences we have carried out inside this labora, as we call this lab. And one is about feeding, because we went to this Pere Virgili hospital and showed several possibilities of developing applications, and they said, oh, feeding is the killer application. We have 50% of our patients need that they are fed, and our personnel do not have the time, and we ask relatives to come, but at lunchtime they rush, and it's not a pleasant experience. So if you could develop some application in this regard, it would be fine. So the first prototype we did in our lab with the one robot we had there, and has a camera, RGBD camera. So when the person opens the mouth, looking at the camera, the robot feeds her. The robot has in the wrist also a force sensor, so this guy closes the mouth at the moment the spoon is going to enter, so the robot stops, withdraws, and waits for him to open the mouth. And moreover, this guy just closed the mouth with the spoon in, so the robot didn't break his teeth. It waited and withdraw, and they have fun, our PhD students in our lab, as you see. So we developed, together with the management in the hospital, the innovation department, the medical personnel, the nursing personnel, and the caregivers, and a new prototype with first miniaturizing. We found this little arm in the market, actually, and substituted all the electronics. And also, they asked for changing the tool, or the cutlery, not just a spoon, but fork also napkin to clean, also something to drink, because they wanted this to be autonomous. The person using this tool could be completely autonomous. So we performed experimentation then with patients, actually, in the hospital. And to our surprise, they wanted to incorporate this face you see here, because they wanted to interact with something, even if we told them, no, this is just an appliance. It won't understand you. It's just like an intelligent, between quotes, appliance for you to be autonomous in eating. But they insisted and insisted, so we finally placed this face. And well, at the beginning, we had an experiment then with 60 patients, and at the beginning, there was an association of patients that was very reluctant, because they say, oh, at lunchtime, the patients get some warmth from people that feed them. And well, they were saying so, but the patients enjoyed it very much. They went on TV, local TV in Catalonia, to say so, that how wonderful it was to interact with this machine that gave them autonomy, and that their relatives could come whenever they had time and talk to them, not just be machines that fed them. And so the association changed their mind, and they also went on TV saying that this was a good development. Another prototype we developed was with the Fundació ACE, which is an Alzheimer association for the diagnosis and treatment of Alzheimer and other mild dementias. And they, in the daycare facility, they have like 20 patients and one therapist. And with this type of board that has numbers, or can have letters and so on, they tailor an exercise for each patient according to the discapacity they have. And then they play. But the therapist has a hard time, because has to play with one, with the other, and give encouragement, record data, so it's very time-consuming. And they ask us to just have also an arm, like the one I showed for feeding, but this is the robot we had. It's from PAL Robotics modified, and we modified because in the first experiences, it was the regular Tiago robot with 2 cameras that looked at the board and identified the pieces. And you see, this type of patients doubt a lot. They pick up a token, for instance, if they have to order in increasing order, pick up a token and look at the therapist. And the therapist usually makes some gesture. And then they leave it if it's not correct, and so on. So the interaction that was verbal was a bit slow. And this decided us to put this face on, printed with a 3D printer, and to give direct reinforcement or feedback. And also we sensorized the board so that when a token is picked, the robot knows which one it is. So this is a short video showing, well, the voice is in Spanish, and there is a translation in the board. So you will see that it provides reinforcement.
Recuerda, estamos ordenando los números impares desde el más grande al más pequeño. Es tu turno. Por favor, mueve una ficha.
You see the person doubts a lot.
No.
And he immediately provides feedback.
La respuesta está aquí. Es tu turno. Por favor,
So
mueve una ficha.
can indicate where give help, where the token lies, the one that needs to be taken.
Perfecto. Muy bien. Me encanta jugar contigo.
Give some encouragement also. So we developed this, again, in co-creation with the management at the foundation, the neurologist, a clinical therapist, and a social worker. So very quickly, the other aspect, ethics. It's very important to share with all the involved parties. And I claim in this paper, you see here, that embodiment makes a huge difference. Why? In relation to AI, I mean. Why? Because the deployment of robots is much slower. So this gives us more time to reflect and to come up with regulation and education. And while in other technologies like AI, usually the development of regulations lags behind the development of technology. And co-design is also, and I won't go into details, but there are some risks that are increased, others are decreased because of embodiment, and also new risks arise, as for instance, when the patient, for instance, is moved from the wheelchair to the bed or vice versa. So I developed a course to teach ethics in social robotics and AI. And it's based on a novel, because I like science fiction a lot, and I write novels. So it contains an appendix with 24 ethics questions, and an online teacher's guide, and a 100-slide presentation, which you can download from my webpage of MIT webpage. There is a high school version that is reduced in Spanish only. And these are the type of questions for the section on human-robot interaction and human dignity. I won't go through it. And to conclude, I like to say that there are very encouraging perspectives ahead. I was in this European Social Services Conference a couple of months ago, and I saw clearly the interest in investing in social robots, the social services, because these will cope with population aging and shortage of caregiving personnel. They realize that elderly people could live longer at home if they had some technological help, that robots can take on tasks that do not have any added human value. And therefore, this could increase the autonomy of the elderly, raise the qualification also of caregiving jobs, because they had to manage technology and they could take care of several people at once, and reduce the burden of the healthcare system and for families. So this is what I wanted to say. Thank you very much.
Thank you for giving us very important ethical viewpoint too. We would like to have the one questions. Anyone, please raise a hand, please.
Hi, I do have one question. So you said at the end that these robots, I'm in the middle, whatever. But
raise your hand. Where? Sorry.
over here.
Ah, okay.
Yeah.
Okay.
So what I wanted to ask is, if you look at the robots that you showed that were very impressive, I wouldn't say that they're, the cheapest to build. And so if you're thinking of, in the future with the aging population, of helping people out, do you really believe that it is that form of robotics that, costs a lot of money that will really be able to take over for caregivers?
Well, we used the robots we had at our lab, but as you saw in the feeding one, we miniaturized it. I mean, and actually we are now building our own arm, very small, and put this sensing in it, which is cheap. So the idea of involving administrations and companies that could commercialize it is precisely this, to come up with a cost-effective instrument that the social services could afford, and that companies had an assurance that they would sell many components. That was the idea. To get a cost-effective kind of utensil.
Great, thank you.
Thank you. Thank you, Carme.